Hello everyone, good evening. So before starting our session, let me confirm with you whether my voice is clear. Are you able to see my screen? Let me post a poll regarding that. Yes, guys? Yes. Okay. So before starting our session, let me briefly introduce about myself. My name is Shrija Depuru and I am working with 360DigiTMG. And today we are going to discuss about cloud computing, and we will talk about cloud computing. And there are when we talk about cloud computing, uh, we there are giants like AWS, Azure, GCP, and IBM Watson. And we will talk about AWS and Azure, and also GCP. What are the famous popular platforms on these clouds? So that's what we are going to discuss today and tomorrow. And also today we will discuss about AWS SageMaker, a walkthrough. So we are not going to discuss go into much into programming. We will discuss about what is this data science, machine learning, and what cloud provides us, and how they makes our life easy by providing all these tools. Okay. So let's start with talking about what is cloud computing. So most of you might know cloud. Cloud has become a big hit, famous. It's a very groundbreaking technology, we can say. But let's start it from the scratch, from where it all started. So we will discuss about cloud computing. Simply put, cloud computing is delivery of computing services like storage, networking, computing power again, CPU, analytics, intelligence, and a lot more, web hosting and other things. All these resources are provided on the cloud, and you don't need to maintain them by yourselves. And that is the advantage with the cloud. You don't need to bother about setting up them, maintaining them. You just go use them and pay for it, like on pay as you go basis. That's what cloud say. So that is a definition of cloud computing. So simply put, cloud computing delivers you services, you use it on like rental basis, but you don't know actually where they are physically present. So on what computer are you actually working with, which hardware you're using, actually where are they, you don't actually know that. You log into your portal and you use them remotely, and that is the beauty of the cloud. And with this, you have now the flexibility, you elasticity, scalability, and with the cloud your businesses can become globally available, and there is no need to maintain other things like setting up the hardware, maintaining people for who work with that hardware, and you don't need people who have skills maintaining the servers, all these things. And it eliminates all these things, and businesses can actually focus on their business itself. So that is the beauty of cloud, and that's why it has become a big hit, and today we are experiencing everything online. So all these things, for all this transformation, cloud has a driving force for all these things. So that's cloud computing. And even before cloud has started, we have servers, and we have web pages. All these things are there. Business are there on online even before this cloud has started. And through this client server architecture, client server architecture has been introduced long back ago, and even cloud and how it works. We have client devices. Say let's take an example of some grocery store like Walmart. They have branches in different regions, and all the computers all around these regions and their stores, they have centralized a server and they maintain their own servers. And maybe the person who is at billing counter can retrieve information from the server, or he can update some information in the server's database, like maybe acknowledgement of receiving some product, or some product might be out of stock, or other operational management details. He can update it in server's database, or he can retrieve some information from the server, like product details, price, etc. Let me close this. Okay. And then they used to maintain their own servers, and obviously when there is like peak time or festive season, or Walmart has declared some discount during that period, the number of people visiting their store, and also they maintain an online page, a web app where people can order online. So number of people visiting to the store as well as number of people visiting to their web page obviously will get increased. And to handle this traffic coming from all the salespersons and from the different regions, and also traffic coming from the users who are purchasing online, both will increase. Video is not visible, is it? Guys, please confirm, are you guys not able to see my screen? Okay, let me post a poll. Pranita says it's visible, we can see. Then might be network issue at your end, Sai Kumar, so you can refresh your page. Just refresh your page and check once. And around 90% of you says yes. Maybe network issue or some latency delays might be there due to slow internet. So refresh your page and check, guys. Who are not able to see the screen, please refresh or rejoin. Okay, thanks for your response, guys. And back to our topic. We are talking about this architecture, right? Clients are the computers, and server is one centralized computer again, which serves clients. Suppose client requests for some information, it will send it as a response, or sometimes server executes programs, we call them as server-side scripts, and sends the response back, sends the output as a response. And we know this client-server architecture, and this is the backbone of our internet. If you're Googling something, you're sending request to Google server, and it is sending back to responses to you. And fine, as long as it's happy. But when there is traffic, as I said, traffic has been higher than the normal traffic due to multiple reasons, and now what they want to do is they need more load balancing computers and also more servers. So they should go and set up that infrastructure, they should buy the hardware, they should set up licenses, and again they have to do all the things from the scratch, and they have to invest money on that, operational costs. And after once the traffic has become normal coming to their store as well as to the online web app, when it becomes normal, they don't need the extra hardware anymore. And these are the disadvantages when they have their own servers. So people like Amazon, Microsoft, these guys come up with cloud, and the first cloud has been started as Salesforce, and then in 2010 AWS came with the concept of providing services on demand on some rental basis. So after this advent of cloud, we know we are experiencing everything as an online. Now same Walmart, what it will do? Now they don't need to maintain their own servers. They will just go and buy some servers on AWS or Microsoft Azure or on GCP, and their servers will be maintained by those vendors, but application is maintained by these guys. When traffic is more, they will go and buy more servers, and even they can choose some option called as auto scaling. So even if your traffic is more, your cloud itself will take care of such things. So when traffic is increased, it will add more servers like that. So these are all the advantages with the cloud. So let us understand what this cloud actually offers us. Let's take an application. So same application like some e-commerce site. We all use e-commerce site, right? For shoppings, for other things. Nowadays, as I said, everything has become online. A lot of e-commerce sites, healthcare, restaurants, IT businesses, everything has become online. And this client server architecture is there in companies. So in your company, group of employees will log into your company server, and you will access company storage, maybe on premises, maybe on cloud. And now we know how this client server architecture works. There will be one system centralized, other systems will connect to it, get data from it, or request. So based on the request, that computer, which is called as server, will serve. And now the concept is we are going to move these servers to cloud. So what actually our application, which is going to run on these servers, want? So for any application, it needs computing power, which is a brain. We call it as CPU, compute power. So your cloud offers you that compute power. Your applications will run on cloud servers. It utilizes some compute there, and there are of various types, various sections again. So cloud offers you a compute, a CPU. Sorry guys, I got disconnected for a few moments because of my internet. Let me check with you. Is my voice clear now? Let me add a poll here. Yes, no. Am I audible, guys? Yes. I see around 95% yes, now 90%. Okay. Anyway, we'll stick up with the majority. Okay, we discussed about cloud, right? What cloud offers you, what your applications need. What your applications need. Your applications will be running on the cloud, any application. It can be your web page, your web application, any other service. It needs some compute power, right? So some compute power, that is your CPU, along with some memory. We call it as programming memory, RAM. And cloud offers you that for your applications. And storage. In our computers, in our local computers, we call hard drive, right? In the same way, cloud also offers you hard drive kind of a storage. That is one kind of storage which you can use for your virtual machines. And also cloud offers you globally available storages like object storages, and AWS calls them as S3. Azure calls them as blob storage. And GCP also offers you some globally available storage. They are not local to one computer. So that kind of storage is offered by the cloud. And network attached storages. That means a group of computers which belongs to the one network. You can create a virtual private network on cloud, or you can use the existing network, cloud's network. So those group of computers can be attached to certain storage systems. So again, you have databases. These are different services offered by the cloud. Cloud offers you storage, which you can make it local for your one device, or you can go for network storage, where that storage is available for a group of devices in that network. And cloud also offers you global storages and databases for your structured and unstructured data. And also there are different storage services like Dropbox, Google Drive, and they belong to different cloud service. We call as software as a service. Anyway, we will also talk about that. Cloud offers storage, and cloud offers databases, as we discussed, and databases also comes under storage again. And cloud offers network, right? Suppose my device want to become a server, my laptop. It needs some applications, server-side applications, to be installed on it. And these applications use some compute power, some storage, and then network. They have to connect to internet, right? So in the same way, we apply the same analogy to cloud. For your applications, cloud is offering you compute power, cloud is offering you storage, and then cloud offers you networks. So you can have your own virtual private network on the cloud. Cloud also allows you to do so. And then these are the basic components: compute, storage, database, and networking. For any applications, server-side applications or any other applications, need these basic components. And the cloud offers us all of these applications. Okay, where it is? Maybe let me go back. So these are the basic components for any applications, and cloud offers you them. And then cloud also resolves one serious issue called server sprawl. Many enterprises, especially IT corporates, face this issue called server sprawl. Usually, what application developers will do is they'll create applications and they will assign one server to that application, and they will left some space for that application. Maybe when the application is in peak in demand, it needs more compute power or it needs more storage. For that reason, they will assign some server, and they also uh, like assign some space to it. You can assume like that, some computing power, some storage extra to it, so that when application is in peak in demand, server might not get hang out. So it's a nice step to take. It increase the efficiency and reliability of the application. But what happens in ideal scenarios, when application is in normal usage, only 30% of that CPU capacity of the server is used, and the rest of the thing is kept unutilized, untouched. It's waste. Even though a company has 10 such servers and 10 applications are running each of them, and each of the server's capacity and other resources are underutilized, and it's a serious issue called server sprawl, and a company have to maintain all these things, and it's an extra cost, and then they are not used to their capacity. Cloud resolves this, right? Cloud, you don't need to bother about all these things anymore. Cloud assigns you, and you can go for something called as auto scaling. When your application is peak in demand, cloud will check and take care of all such things. So there is one more advantage and the issue resolved when you go for cloud computing. And then cloud brings down your capex and opex, capital expenditure and operational expenditure. So suppose some organization decided to have their own setup of servers, maintaining their own data center, they have to spend some money on capital expenditure. That is means setting up the computers, hardware, buying licenses and everything, which is one time. And then operational expenditure, which is spent for maintenance, for electricity bills and other bills, for paying employees and other such things, is operational expenditure. So your capex, which you spend, might be valid for say next 7 years. And hardware, again, they will become slow. You have to spend the money again. And when you move all your infrastructure or your application to cloud, obviously there is no capital expenditure at all. Only there will be operational expenditure which you pay for cloud, and again that is also less when compared to having your own data center. And anyway, we have discussed about cloud computing and the disadvantages you have when you have your own data center. Of course, when you have your own data centers, people say in some perspective, data is in your on premises, it is more secure. But who knows? So cloud, it comes with multi-factor authentication, security certificates, and other things, and they store encrypted data with them. Maybe when you have your data in your own data center, maybe it's secured, but who knows? You may not follow the advanced firewall system, right? So all I say, cloud also provides you better security. So what is the main point of cloud computing? These are the just requirements. So Abdul Rahman says the main point of cloud computing is reducing the cost, everything, right? So the main point of cloud computing is providing services, your services on utility basis. What does this mean? You are using electricity, you are using water, but you are not worried of how actually that wires are laid, how that electricity grids are maintained, and how pipes are working, whether there are any leakages, and how they are coming to your house, you don't need to actually bother about all these things. You use those resources and pay for them. And that is the concept of cloud, and that is the point of cloud. You pay as you go, you use and you pay, like how you use your utilities. So in short, that is what cloud is. And what are those resources? Like we have electricity, water, etc., we use as utilities. We can use cloud's compute power, storage, networking, and analytics as a utility, and you can pay them on monthly basis, like how you pay your power bills, phone bills, etc. And compute power, here are some examples on what cloud provides you as a compute, storage, etc. So rather than discussing here, I will go to my AWS console. Let me share my screen. Share. Yes, for some reason it might be my Mac issue. I'm unable to share my screen. Let me check with you guys. Is my screen visible? Yes and no. Publish. I will stop my slide share and share my screen. Is my screen visible now, guys? Are you able to see my screen now? So if yes, you should be able to see my AWS console. So 50% of you says yes, 50% no. No. Okay. Now my parent is Chrome tab. Okay, I'll say my AWS management share. Now guys, not visible. My AWS management console. Yes, okay. Still most of you says no. I think it has to. Yes, visible. Okay. Yeah, this is my AWS and how to create an AWS. It's pretty intuitive. If you go and search for creating an AWS account, many websites has steps. You can go and view them, or you can do it on your own. It will ask you your details like your name, etc., etc., and it will verify you by your phone number. It will send OTP something, and it will verify your authentication, the details of your credit card. You have to provide your credit card details, and to verify it, it will deduct some minimal amount, I think 2 rupees, to just check whether they are valid details or not. And then account will be created for you, and it's free, and free trial is for 1 year. For 1 year, you can experiment with your AWS, use its services for free with some limitations. And those limitations, like for S3 buckets, you can have up to 5 GB of data, etc. And you can go for aws.com/free, and just you can check there what are all the limitations for free tier. And this is my console, and here I'll go to services, and it will take me to this place. And the things which we have discussed, the domains, or these services are divided into different domains. So the compute domain provides you compute services, the CPU and the RAM. We have EC2 instances, which are your virtual machines, and we have Lambda, which we call it as serverless computing. Run code without thinking about servers. That means you no need to bother about which operating system you have to use and other things. Just bother about your logic. If you are ready with your logic and program, you are ready to go. Without having any server, you can just go and have it on your Lambda. And again, you have elastic beanstalk, and all the things which are required will be set up in one place. Your EC2, your Lambda services, and other container services put together in the one place. They call it as elastic beanstalk, especially for web hosting to manage web apps. And then compute, then storage is there. As I said, block storage will be available anyway. It's not listed out here. When you go to your EC2, it will be available there. And then elastic file system, which is like your network storage, and S3 buckets, which are globally available object storage, and AWS backup. All other things are there in storage. And we have databases. If you organization want to migrate to AWS, there are migration and transfer plans and options. And we have Snow Family, where a group of people or a guy comes from AWS and he carries all those devices with him, and he will migrate. He will come in person and migrate all of your data to AWS. So for that, you need to call and check up with AWS and other things. And then network and content delivery related to your network and other things. And these are other things. So under machine learning, we have Amazon SageMaker, augmented AI, and other things. So this is your AWS. So what is the point of cloud? Point of cloud is to provide you all these services. So I am a business. I have a business, but I develop some applications. Say, for example, I have applications developers. They develop applications, but my business is not really I don't have the guys who maintain these networks, guys who maintain the infrastructure, who deals with server operating system, etc., etc. And now I don't need to bother about. If I want to launch a new application, I just no need to go and hire a network engineer or a people who maintain my hardware. I don't need to hire a place, etc. I'll just go and opt the service here, and my application developer will happily work in this place. And as a utility as a service, as we discussed. And this is the AWS. And let me go back to my presentation. Let me share my presentation. Start. Okay. So compute power, storage, networking, all these things are available on AWS, and you can use them on pay-as-you-go basis. Right, and the benefits of cloud, we already discussed, so I'm skipping it. And this is NIST model of cloud computing. So NIST stands for National Institute of Standards and Technologies. They will define conceptual models and set up standards. And they have set up a standard and defined one definition model for a cloud. So suppose you are a guy who wish to launch a cloud, come into the segment of cloud provider. So you should obey NIST standards. So what NIST said is, according to NIST, these are different types of clouds deployment models. Clouds can be public, private, hybrid, or community. Public means the services of the cloud will be provided for all of us, like AWS, Azure, GCP, the ones which we are discussing. They are public clouds. And private cloud is specific to some organization, the hardware, the software, and again it's like a data center, but it's not going to be on your premises, but in somewhere. And also public clouds has come up with a concept of virtual private networks, and you can decide like having your private network on public cloud also, and again that's a different concept again. Public means resources will be shared among the users. Private means resources are not shared among the users, they will be strictly for you. And hybrid is a combination of public and private. Some part you can host on private, some part you can host on your public cloud, like that. Suppose my e-commerce site, all the products which I wish to display, I'll put it on public. I don't bother about sharing the resources with others, but the transactional, when coming to that segment, I will host it on my private cloud. So in mix, it's a hybrid cloud. And a community cloud is like domain specific cloud, like Salesforce, cloud which specifically manages your CRM. So these are called as community clouds. And then cloud offers you a lot of services, and these services can be categorized into three types: software as a service, platform as a service, and infrastructure as a service. And this has become very famous, and many of might be already knowing about this. Okay. Anyway. And cloud should offer you broad network access because it has to be globally available, rapid elasticity. So that's why we are switching to cloud. We need elasticity. Suppose I want more servers, I would be able to do that within a minute. Measured service. So cloud offers you on a pay-as-you-go basis. That doesn't means it has to be a measured service. They have to tell you upfront, like how, on what basis you are going to be charged for. Well, how they are going to charge for storage, how they are going to charge for your virtual machine, computing resources, etc. And it should provide on-demand self-services. What are the services are on demand? So that should be available with the cloud. These are the essential characteristics. And of course, resource pooling, like our carpooling, there should be there. And Prithviraj says your screen is not visible. Okay, is it, guys? Is my screen is not visible? And poll and reset poll. So you guys should be able to see this NIST model of cloud computing. Is it visible? Start poll, publish. Okay, yes. Visible, yes, thank you, guys. So these are the essential characteristics a cloud should have. It should share its resources. Along with that, it should have all these properties. And these are different deployment models, and these are service models. And let me quickly explain this SaaS, PaaS, and IaaS. So IaaS, infrastructure as a service. So we will start from SaaS, guys, because it would be easy to relate. We are already using this Facebook, Google Drive, Office 365. So we are using Office 365, right? We are using Google Drive, Google Docs, Google Spreadsheets, all those things. And what actually needed to use this? Nothing to install on your computer, just a browser and an internet connection. With the help of these two, you can create PowerPoint presentations and Word documents. You can store your data on your Google Drive. So these are SaaS applications, software as a service. These clouds, Google, Microsoft, they are providing their services and they are entirely maintaining them. These are called as software as a service. We generally get this software as a service. Entire things are maintained by cloud itself. You just pay for licenses. Suppose your company want a mail, company mail IDs which are specific to your company with your company name or something. It will approach to Google and asks to provide a mail system for them, and they will pay for licenses every year. And this is a SaaS, software as a service. And then IaaS, infrastructure as a service. Suppose your business, you have entire things with you only. You only need some extra support. Like we took an example of Walmart or any e-commerce site. They already have their servers, etc. With them. They only need extra infrastructure. So that infrastructure might be, their existing infrastructure might be on premises or on cloud. But they need an extra infrastructure, and they need only infrastructure. They have their application with them, they have their data with them. Rest of the things they maintain by themselves. They need only a virtual machine in simple. They need one computer with some OS. That is infrastructure as a service. And Kubernetes, Docker, virtual machines, all these are example for IaaS. When I say virtual machine, you can assume a computer which you can virtually access on its operating system, Windows, Linux. And you can have virtual machines without operating systems also. Those are called as containers. And Docker, these are all containers. These belong to infrastructure as a service. And PaaS, platform as a service, is in between these two. Let's say I need to create a database server on cloud. What I will do, I'll go and get a virtual machine, and that service belongs to infrastructure as a service, and I will install my database management system on it. This is one way of doing it, using IaaS service. Other way of doing it is I'll go to database platform itself. Cloud also provides you database. NoSQL, MySQL, relational databases. I'll just go and create one database. That's it. I no need to install. I no need to maintain it. I no need to check it, organize it, like how it is, etc., etc. That is platform as a service. You need a database. Data is yours. You're going to access it. You're going to write it, retrieve it. That are the things is up to you. But the service, the platform, cloud offers you ready-madely. That is platform as a service. So many platforms, not only databases, are available in AWS, GCP, and Azure. Platforms for web hosting, platforms for IoT applications, platforms for analytical applications, platforms for databases. So it's a platform as a service. Is this clear with these terms? Let me post a poll. Any doubts? Any doubts, guys? Yes and no. Let me publish this. Okay, let me check a poll. Doubts, yes. If any, yes. Okay, 25% of you says yes. Doubts, then you can type in the chat box. PaaS, platform as a service. See, suppose you want to develop a web page. what you need. Suppose you're working on your own computer, you need to develop an web page. You are developing some web app. You're working on that. You need your Apache server or MySQL server, these kind of things, right? You'll install them, and you'll have an application server, and then you'll have a database server, which is front end and back end servers. You'll do all these things. The same thing you can shift to cloud. You can go and create one virtual machine. You can assume like buying a computer, and you can decide operating system of that computer, capacity of computer, etc. That is IaaS. So under IaaS service, you are creating a virtual machine. No, PaaS is not equal to web hosting. It's just, I'm taking an example. So and then what you'll do, you will install your Apache or these kind of server application on it, and you start working it. So this is one way of doing. And cloud offers you one more thing called as elastic beanstalk. Cloud offers you a service called Lambda. You can just go in that platform, just you bother about your code, your PHP, Java, other things. Just you bother about your code, you run your code there. You no need to bother about installing your Apache server, rest of the things. That is platform as a service. Elastic Beanstalk is already available for you. You just work upon your code. You no need to maintain other things. That is, the platform is created for web hosting. You can work on with that. In the same way, databases. You no need to bother about installing a database, maintaining it, upgrading it. Go for it. It's already available there. Suppose you want to set up one IoT application, a smart environment at your home, connect devices to cloud. IoT platform is there. You no need to write APIs, how to connect this device to cloud. You no need to do it that work from the scratch. Cloud available, make the service available as IoT platform. Sorry, that is PaaS, platform as a service. So these platforms are available like in every domain, not only for web hosting, for IoT, for data science, for machine learning, to store data, databases again. For all of these things, platforms are available. So that is platform as a service and software as a service. So someone said like all social media, yes, all those things are SaaS. Your Twitter, Facebook, Google Drive, everything is a SaaS. So the applications which you are using via your browser and internet connection, you don't need anything, you don't need to bother about anything. Those are called as software as a service. Right, so infrastructure as a service is nothing but you will get a bare metal machine. And rest of things is maintained by you. And platform as a service, you maintain your application and data, that's it. That is platform as a service. So EFS is an elastic file system, like a network of devices can connect to that file system and access that storage. So it's a network attached storage. So PaaS for IoT, cloud provides IoT platforms. What they will do is you just go and register your device, like how you suppose you want to use Facebook, how you will use it? You will go and register, right? First, you will create an account. Like that, this IoT platforms allows to create registration for your devices, and then you just go and program your devices. They will provide you some authentication certificate or any encrypted key, and cloud allows you to send data from that device. So you no need to bother about rest of things, actually writing APIs, other things. So everything is readily available for you. You just want to use it, play with it. Mobile app skills ID create in your side. So mobile app, again, you can do it on cloud. It's a different one. So Neha says no voice. Maybe refresh your page. Okay. And then what do cloud contain? So let us understand this cloud service, different services using this pizza analogy. Like this is IaaS, guys, infrastructure as a service, made in house. That means made on cloud. So everything has to be maintained by you, right? Kitchen, gas, oven. Suppose you feel like eating pizza, but IaaS provides you environment. That's it. Rest of the thing has to be um, maintained by you. Your kitchen, gas, oven. You are responsible for all of these things. And infrastructure. Sorry, this is our data center. Made in house is our data center. And if you go for infrastructure as a service, uh, kitchen is provided for you with gas and oven. You have to make your own pizza. That is infrastructure as a service. So your computer along with OS is available for you as an infrastructure as a service. You have to decide what installations has to be done, what applications has to run, and how they are developed, how they are maintained. It's you maintaining them. That is infrastructure as a service. And then platform as a service. Right, toppings, cook the pizza. You don't need to bother about rest of the things. Cloud provides you all the ingredients that has to be there on the pizza. You just choose, customize it. And software as a service is like readily available pizza, right? And so I need a SPAS for IoT. Again, it's a different topic. If I go to PAS, means again how devices are registered, how data is generated, all the things. So what is access key ID? So just now I have told, right, your platforms are available and you can connect your devices to your platforms. But cloud is secured one. It allows data only from approved devices or approved users. Suppose you are programming certain source or certain device to send data into cloud, it should need access key ID. Access key ID is like a authentication. Yeah. Yes, guys, hope clear with this service model, SaaS, PaaS, and IaaS. Okay, so cloud services and the software as a service. As I said, you can develop a software as a service using public clouds, and we took some names of software as a service: Google Drive, Office 365, OneDrive, all these things. And what these public clouds, the clouds which we are talking, the popular clouds in the market, AWS, Azure, Google, IBM Watson, what they actually provide is infrastructure as a service and platform as a service. These two kinds of things are offered us. Okay, guys, and then there is one more service called as analytics as a service. It's not defined by NIST as in its standards, but it is a mixture of infrastructure as a service and platform as a service. Analytics as a service. Cloud is not only for compute power, storage, network, and most of the analysis is done on cloud. So cloud is a central point of analytics. Cloud also provides you analytics as a service. Cloud offers you machine learning platforms, storage platforms, data lakes, etc. Okay, guys. Before talking about these analytical platforms on cloud, let us talk about few things like IoT and data science, big data, and relation between them. Okay, and before moving on to this topic, let me post a poll. Yes. No. Yes, guys. Any doubts with cloud? I hope you guys are clear with cloud, especially different service models in the cloud, SaaS, PaaS, and IaaS. And also, we discussed that cloud provides you another service, which is analytics as a service. Here around 93%, yes, clear. Okay. And then I'm not audible. Okay, let me check with others. Guys, am I audible? Around 85, 82% says yes. Okay, guys, maybe slow internet. Refresh your page once or reconnect. Okay. So that's about cloud and different service models in the cloud. And coming to analytics as a service, before talking about it, let us understand how data is generated and what is the need for analysis and why we are talking so much about data analytics, IoT, big data, right? These terms are like hotcakes in the market, emerging technologies, we say. So all these things are actually interrelated, and the common things on all these emerging technologies is central point is cloud. So all these are based out of cloud as a central point. Let's start with understanding IoT or IIoT, Industrial Internet of Things, and IoT is a generic term where IIoT is Industrial Internet of Things, IoT used in industries. So this IoT refers to interconnected sensors, and these sensors can be in instruments, trucks, and our smartwatch is one example of such device which is equipped with sensors, right? It tells your heart beat, number of calories burned, number of steps you make, and how it is able to do all those things. It has sensors in it, and it's communicating this data to cloud, and that's how you are getting insights. You're getting message that you have only 6 hours of sleep this week, your average sleep cycles, and you will be getting suggestions that to increase like to decrease your calorie intake to achieve your goal, fitness goal. It will come up with some food and exercise suggestions, and how it's all happening. Data is getting transferred from your device to cloud and getting analyzed there. So IoT is nothing but devices, they generate data, and these devices are equipped with sensors and other electronics. These devices, we took example of smartwatch, they can be watches, they can be bulbs, they can be conveyor belts like this in the industries. You can see a conveyor belt here, right? And or a machinery or a watch some field engineer is having within the field. All the data is carried to cloud and analyzed there. And since these sensors, they generate data second to second, huge, humongous data will be generated. And this data is considered as big data. And what is big data? When data is very huge and the conventional models cannot handle the data, it's called as big data. So big data comes from different areas. Your social, maybe social media data, transactional data, other data, and IoT data. So all these data considered, we call them as big data. And IoT and big data has a relation, like IoT generates data and it is considered as big data. Now, why we need sensors everywhere? Why we are collecting all the data? Because it has to be analyzed, and outcome of that analysis is something from which we can benefit. So let us take one example. This IoT environment is in machinery. Like in some factory, a machinery is equipped with sensors. Like that, there are like 50 machineries, and all the data put together, the amount of data generated is big data. And we need certain tools to handle this big data. And those tools are provided by cloud. And then it has to be analyzed. Some machinery is sending a data which vibration temperature levels are high. Your analysis model which is running on the cloud will tell that, hey, certain machinery is vibrating too much. Maybe you have to stop the machinery for some time. You have to service it, or you have to replace some parts in it. So without machinery, we are stopping there. We are stopping machinery to break down and predicting what's going to happen in future. Based on that, we can take preventive measures. So we can benefit from analysis. If we analyze the data coming from environment or from an object, we can benefit out of that data. And you can take example of your smartwatch also. You can benefit from that data. You know what is your metabolism rates. You know what is your sleep cycles, and further you can enhance your wearable, and you can calculate your blood pressure, sugar levels, etc. And data has to be analyzed, then only you will get that benefits. So in short, is IIoT related to automation? Yes, IIoT is related to automation too. So this is relation between big data and IoT, and then data analytics, right? Data science we say, and data science is not a single domain; it's an interdisciplinary domain, you can say. So data science is a topic which deals with how to process your data mining, because you will be taking data from different platforms, some from devices, some from social media, some from other platforms. It has to be transformed, cleaned, processed. So that is one shared in data science. Step one, you can say. Big data, and again, how this data is streamed to your models, by using which tools, which stream engines, all these things, big data, and machine learning. Finally, what to do with this data? You have to analyze. How? I'll write an algorithm to tell if there is any variation in my machinery vibration levels, it should send an alert. That is my machine learning model. So that is data analytics. So all these three things are interrelated, and they are connected at a central point called as cloud. That's why we are talking about all these things. IoT generates big data, humongous data, and that data has to be analyzed, and that will happen again in the cloud. And this an analysis process, we have data mining, big data tools, and machine learning. Right? So cloud is central point for all of these things. You can generate reports, write queries to your databases. Cloud provides you analytical tools, and you can train your machine learning algorithms on cloud. Right? So is this concept of IoT, big data, and analytics clear? Any doubts? No. Okay. Around 90% says no. Most of you says no. Yes, guys. So now we will see how they are interlinked in the cloud. What cloud actually offers us, right? Your IoT, big data, and analytics. And here we have something called as machine learning, right? We know uh, what is data mining. Data mining is cleaning of your data, getting it ready uh, without like in some format. And then what is machine learning, right? Machine learning is a concept of teaching your machine. Like when let us consider your mission as some newborn child. When we are born, we don't know anything. We don't know to talk, walk, how to behave. We don't know about environment, right? As we grow through our sensory system, uh, by learning, by observing, we know all these things. In the same way, machines are our computers or any other devices, like some advanced IoT devices or um, computers. We teach our machines. That is machine learning. Like how that process will happen is, let's say I am teaching my machine to identify animals. I can program it. That's what we are doing. Just go and program. Like when cat image comes in front of the camera, you have to tell it's a cat. When dog image is given, you have to tell it was a dog, right? And what you will do in your program, you will say dog. You will define characteristics of dog, color, height, and how it appears, etc. What if a different kind of a dog comes in front of your programming, the computer which you have programmed? Obviously, it will get confused. It will say it is not a dog because in its program, it has been said that dog will have two eyes, a mouth, and its tongue outside something. You'll define some characteristics, color, etc. And this new dog will not meets its requirements, all of its requirements which you have mentioned in the program. And that's what will happen when you program your device. But when you teach through machine learning, what your machine will do is it will understand, capture the features, and correlate with the dog's data set already available. And it will check most of the characteristics. Suppose like this, if someone comes with a dog mask, your machine learning algorithm now it should not say that human being who has this dog mask as a dog. It has to compare. It has to compare and tell something like this: 14% dog, 85% Elon Musk, or it actually should decide whether it's a dog or a human being. And again, it depends upon how accurate is your model. So machine learning is something, but you teach your machine with your data set. You will provide a data set like pictures of cats and dogs and other animal pictures or its data set, and you will write an algorithm. So what this algorithm do is not only identifies the dogs, if any other thing which is relatable to dog comes, it will decide whether what animal it is, and if it is a new dog, it will change its data set, and that's how it's learned. That is the concept of machine learning, and it appears to be simple, but it takes a lot of effort on building a machine learning model. And cloud now has come up with a solution for that. You can actually use cloud tools, which saves a lot of time and effort. We are going to talk about that now. Okay, try reconnecting the red button at the. Okay, guys, clear about the machine learning? Start poll. Yes, okay. Yes, just give me a minute. Okay, guys. And before talking about AWS, let me share my screen with you. Okay. So here you can see analytics on AWS. So what we have seen, a data science or to build a prediction model. Let's say take an example. You need to build a prediction model when a machinery breakdowns. Suppose it's a cement manufacturing company or a mining company, and it has a huge machinery, and you have to predict uh, whether the machinery breakdowns or not. The first step, what you'll do is you'll go and set up your sensors, everything in that environment. You will connect it to IoT platforms of these clouds, AWS, Azure, or GCP, whatever the cloud offers that service. You'll connect it to that cloud, and then all the data will go to cloud's database. And from there, what you'll do? You have to do analytics, and there are scalable data lakes. Say big data, right? So how you handle this data? 10,000s of customers run their big data lakes on AWS, and AWS has S3 bucket where you can store petabytes of data, and it has process built analytics service and a seamless data movement, all these things there, and they are also categorized in this page. If you can see, for analytics we have Amazon Athena, EMR, Amazon EMR, which is a Hadoop framework, comes under big data again. It has Redshift, and if you want to do real-time analysis, that time when data is generated, in recent times, we are hearing this, right? Gas leakages, all these things are happening within the factories. Suppose if the factory takes a preventive measure, like that data has to be analyzed in real time. There will be sensors around that factory in that gas plant where the leakage or the gas terminal something, and their sensors will generate some data which are analyzed in real time. At that point itself they are analyzed, and such services are also available in Amazon Kinesis. They are analyzed in real time, they produce insights in real time, so you can avoid such situations, right, when you analyze data in real time. So Amazon Kinesis allows you to analyze data in real time. Operational analytics is there using an elastic search service. You can create dashboards and visualizations, which is the first step in analysis. You can use Amazon Quick Sites. So if you want to know how temperature is varying, if you look at an Excel sheet of full of temperature, you will not know. Obviously, you have to plot it in some sort of graph or visualization, and these tools will automatically do it. You just have to provision them, go create them. That's it. They will do, and of course, connect your streaming data to them, and these things will automatically happen. And real-time data movement, these are the services used for that. And then you have data lake again, S3, uh, lake formation, AWS backup, all these things. Again, for predictive analytics and machine learning, we have AWS deep learning platform, AMIs, Amazon SageMaker. So all of these things which I have talked about, they comes at a platform as a service. All of these things are platform as a service offered by AWS. And the same with sharing off. Let me share another tab because I am not able to share my entire screen. I have to switch between my tabs. Share. Right, and again the same thing. Only the names gets changed when you go move on to from one cloud to another cloud. But more or less, all the services will be available in these enterprise level clouds like AWS, Azure, GCP, IBM Watson, all these clouds, right? And we have Azure Synapse Analytics for limitless analytics service, Azure Databricks, and again Azure offers something called as Azure Stream Analytics, right? And AWS calls it as Kinesis for real-time data processing. And in Azure, they are calling it as Stream Analytics. And there is Data Lake Analytics. In AWS also call it as Data Lake. And the Data Factory, machine learning. A machine learning platform is there, and AWS calls it as SageMaker. Only names gets different. The terminologies, how they portal appear different. But if you get used, if you are strong on your basics on working up with one cloud, and when you move to other cloud, it's intuitive. You can automatically learn about all these things. And you have Azure Time Series Insights here, where you can schedule things. Like suppose data coming from my machinery, vibration levels is high. I can go and send an alert here. You can monitor, analyze, and visualize using my Azure Time Series Insights. So all these things are there on Azure. Okay, let me go back to presentation again. And this is Gartner's Magic Quadrant. Gartner is a famous research organization. It will be giving this Magic Quadrant every year related to all the technologies. And coming to cloud, it has rated AWS in the leading position, and Microsoft is in next. And they have like a minute difference, AWS and Microsoft. And AWS also holds around 60% of the market share. And of course, Microsoft is coming closer to AWS. And Google is a new entrant. It's a new entry in this cloud provider section, and it is there. And these are the things when we are talking about cloud providers leading in the market. And so we will talk about analytical services offered by each of them. I'll walk you through like a few services, analytical services offered by AWS and Azure. So here, Amazon Web Services, as we already discussed, you can go and have an account. You can use it for free for 1 year period of time, whereas it's only 1 month for Microsoft Azure. So Microsoft Azure gives you only 1 month of free trial, whereas AWS offers you 1 year of free trial. And before starting with AWS, you have to know about its regions and availability zones. What are they actually? To know about this AWS regions and availability zones, we will visit their website on called AWS Infrastructure. Let me open in a new tab and then I'll share with you. Anyway, let me share my tab again. Chrome tab. Share. Here, I think this is not the right link. Let me say AWS/infrastructure. Okay. Anyway, so let's understand about its different regions. And AWS is available globally and across 190 countries, and it is available in different regions. And AWS have also created a portal where we can navigate through different regions, but I think I lost that link. I'm not finding the exact link. Say, let me try one more time. AWS infrastructure, and okay, it's infrastructure.aws, guys. It's like, I feel it's very engaging portal, and they have created this infrastructure.aws. You can go and visit there, and they have shown us all the regions where they are available. You can navigate, rotate across this globe, and this is a projection type where you get this map view. And in this map view, these are all the regions where AWS is available. And in our country, it's there in Mumbai and Hyderabad. I think Hyderabad not yet available, coming soon. And Mumbai, it has 3 availability zones. What are these availability zones? First of all, what is this regions? Cloud is nothing but a data center which is globally available. That's why we have talked about client server model at the starting. When you have servers maintained by yourself, it's called your data center on premises. And what is cloud? Cloud is offering you those servers, those data centers, and services within that data centers on a rental basis. Cloud is nothing but distributed, humongous data center. And in Mumbai center, we have this AWS data center. Mumbai is a data center. AWS is data center. AWS servers are physically available in Mumbai in 3 zones. That means 3 data centers are there in Mumbai. And in Bahrain, again there are 3 availability zones. Yes, AWS is there in Bahrain and it has 3 data centers. And then we have Paris, London, everything. Let me go back to regions again. And North Virginia, it's like AWS testing center, lot of research and other things will go in North Virginia. It has 6 availability zones. That means 6 data centers. And why we need to know about these regions is, when you are developing an application, you should know, right, who would be accessing your application. My business is operated in India, so I want my services on Mumbai region. I am extending my business to Singapore or Malaysia. Then I need my services to run in Singapore region, which is closer to Malaysia also, so that my clients, my customers can easily access my business's web page. And also, suppose your devices are generating data from somewhere, some Bahrain, in some site in Bahrain, devices are generating data, and you should not set up your services in Hyderabad. It has to be Bahrain. So this is the one reason we have to know about the regions and availability zones. And the other thing is, not all the services will be available in all the regions. In North Virginia, most of the services are available. As I said, it's like their home center. And that all the services may not be available for our Mumbai region. That is one more thing. That are things about regions and availability zones. And then going back to our presentation, stop screen share and I'll start my slide presentation. Start presentation. Start. So AWS is a region where its data center is physically available, and availability zones are like um, you can assume like 3 data centers are there, 3 buildings of servers are there in Mumbai. And the AWS, as we saw, it's globally available. When it's globally available, all of its data centers are globally connected. AWS, we don't know how they have laid wires or connected it underwater or underground. All of these things are connected with each other. So if you're going and choosing AWS, if your application is hosted on AWS, um, it is globally available. People can reach you globally. And then we already talked about it. We know regions, availability zones now. Let's skip it. Okay, and then let me check times. Yeah. We talk about Amazon SageMaker also. Yes, guys, before that, let me ask you any doubts. No. Okay. And someone here in the chat box. So how much minute session is left? I think around half an hour, 20 to 30 minutes are left. And explain machine learning once again. Okay, going back to this machine learning, see, machine learning is nothing but teaching your machine. So you can take this machine learning as an example. Your Facebook. Facebook uses machine learning, or you can say AI. Let us stick to machine learning. Say when you upload your class photo or a group photo on your Facebook, it will automatically tag names for each of your friends. And how it is doing, it's mapping the data sets. Facebook have a data set of yours, data set of your friends, and of all the people who are available on your friends list. So it will map the data sets. And there is a new image you have uploaded, and it already have this data set of yours and your friends and all other things. It will map it. So who is actually doing? Behind your Facebook, there is a machine learning developed, machine learning algorithms. They will map this data sets. So again, nowadays we are seeing this artificial intelligence application launched by Google. When you go and click on some restaurant, you'll get all the information about that restaurant, right? Whether it's language, if it is different also, you'll be getting. So again, it's a AI, machine learning AI, these kind of things. Is any skill needed to learn machine learning and AI? Yes, bit of Python is required, and the rest of the things you can learn. So cloud programming. Yeah, cloud is available in a lot of programming languages. You can use your Python, Java, your C language also. So cloud supports all the popular languages. Okay, guys, that's about machine learning. And cloud also offers you a platform for machine learning. And AWS, one such platform is called as SageMaker. Let us go and have a look into it. And tomorrow we will talk about Azure. What are all the analytical services offered by Azure also? Okay, let me share my tab. Okay, share. This is my AWS console, and I will type in as SageMaker. Okay. SageMaker, Amazon SageMaker. It says build, train, and deploy machine learning models. So by this time, we know what is machine learning. Machine learning is teaching your machine. How you teach? By your algorithms. What your algorithms will do, it will map your data sets, map the upcoming image or upcoming data given to it with its data set and will decide. Suppose the data is coming from a machinery, that vibration is too much high, it will map it to that data set where it has too much of vibrations. And then it will say your machinery is going to break down. For some reason, it will analyze and tell you that reason also. In the same way, we took the Facebook example, right? Your Facebook have different data sets, and when a new item comes to that machine learning algorithm, it will try to map that new item with the existing data sets. And that's how your machine will learn. And after that, new output will be updated in the data set. Like that, your data set will be increasing, your machine will be learning through your algorithms. And that again, it's not as simple as that. It will take a lot of time and effort. You have to process your data, you have to train your data set, all these things. And from conceptualization to production, actually, you come up with your machine learning concept model on your paper, and then you'll train your data set, you'll deploy your machine learning, you'll test it and take it to production. Lot of steps are involved and lot of time consuming things are there in this procedure. If you do it manually, and definitely it will take a lot of time and effort, and to minimize that, clouds come up with machine learning platforms. And these days, in recent times, they have also launched auto ML platforms. So we will talk about that auto ML platforms at later point of time. So what cloud offers you for machine learning is, you can create notebook instances, you can train your data sets, you can again interference and processing run. So what all these things mean? Let me go to notebook instances first. So here it's not, so let's go to dashboard. So hope you understood machine learning. First, what we have to do, we have to write our algorithm. What it will do, it will fetch some data in the data set, or data set is not available. In some scenarios, data set will not be available. Then your machine learning will form clusters, similar kind of a data is clustered. And again, there are different algorithms for that. So that is your notebook part. So notebook is nothing but a Python environment where you can have your algorithms. And you train your data set. And you provide an input from where it takes the data. And then you will create a inference. So what this inference means, after creating your machine learning might not be perfect. It has to customize it. according to its performance. And again, it should be on its own. Again, you should not go and set up everything. It has to upgrade by itself. On what basis? You'll tell it in this inference. That's it. And processing run, pre or post processing, model evaluation. So processing the jobs and how your machine learning runs. So that's what you tell in your processing run. So let us create a notebook. So notebook instance first. So as I said, notebook instance is nothing but a Python. If you are aware with Python, Jupyter, it's nothing but another flavor of Python where you can do programming. So a lot of libraries are available. You can just import them and start working on it. So I'll say create notebook instance. And AWS calls all of its things which are running as instances. You can assume like that S3 instance, EC2 instance, which is a virtual machine instance. Here is a notebook instance. And we are creating a notebook. So again, notebook is nothing but an environment where you will be deploying your machine learning algorithm, developing. You can assume like installing Python on your machine. Like that, we are creating a notebook instance here. Let me call it as my test notebook. And then we will keep it as is. It's nothing but your instance type. Suppose your machine learning needs lot of computation power. Then you can choose like ML T3 large or extra large, and the basic one is T2.medium. We will stick upon this medium. Additional configuration. We are not going to touch this part also. You can set a life cycle for your configuration, for your scripts, etc. And then I am role, identity and access management. And this I am portal thing is available in AWS where you can set permissions to users. Usually your enterprise will be there on the AWS, right? Enterprise account. There will be different kinds of employees. Some employees will be working in the marketing department, some in HR, some are developers, some are managers, uh, some are under testing and developing. So you can assign permissions to them accordingly using IAM. And for now, we are not going to touch this also, leave it as is. And IAM role, let me say create a new role and say create a role. Yes, successful, I have created an IAM role. And then the root access is enabled, and I don't want to touch this encryption. That's it. And create a new instance. And here, additional configuration, IAM role, create a notebook instance. So it will take some time to create your notebook instance. And here I already one which is created and it's in service. I'll open it. Open Jupyter. So this notebook is nothing but the environment where you can do your work. So actually, if you start working with your algorithm on your machine, you'll go and install this Jupyter on your machine, which is GUI, graphical user interface, where you can do your work programming. And you can create a new notebook, and other versions are available like Spark Magic, and these are different things. Conda, Amazon TensorFlow. I'll go for Conda Python 3. See, now I am here. I can start my programming here, right? And let me go back. Okay guys, sorry, I think I have shared one tab only. If I open this tab, you might be not to see my tab, right? Sorry for that. Okay, let me share this one. Share. Share. So, right guys, you would be able to see my Jupyter portal. So I have created a notebook, and this environment is called as notebook. This is my Jupyter notebook. And I can create a new notebook here. And these are all different versions available. You can choose one of them, your working environment. And here it is. There are two notebooks which I have opened. And then you have this running. You can get to know which are running. My untitled.ipn is running now. And then clusters and SageMaker examples. So this AWS SageMaker is also providing you with examples which you can work with. So as I said, when you're teaching your mission, there are different algorithms like methods on how you teach, and these are all different things. K nearest neighbors, which clusters your data, and then all these are your machine learning algorithms. XBoost, which is an advanced machine learning algorithm again. And here, factorization missions, so which gives mostly used for predictions. We have talked about examples like predicting a machinery failure, right? So factorization missions is the one thing which is mostly used for that. You can have a preview of that. It opens in a new tab. Might be it will be not visible for you. It gives you a documentation. When you click on a preview, here it is, right? Preview, you'll get to know about that sample. And when you say use, it will ask you to create a copy. Yes, I want to create a copy of it. Continue without kernel. Okay. So this is factorization missions with MNIST. And again, someone who have this machine learning knowledge might understand all these terms. It might be new to you if you don't have a machine learning. So for now, what are all these things are? These are algorithms which is used to teach your machine. And this is a binary prediction of a weather factorization machines. So this is the algorithm name. And going back to my Amazon console, let me go back. Turn on screen again, Chrome tab, my AWS SageMaker. Yes. Here we are, and now I have two notebooks. Notebook instances are nothing but where your work environment. That is one thing. And then you have processing jobs. So what are these processing jobs? We'll say create a processing job and just give a job name, container. So this container is again where your machine learning algorithm you're going to deploy. So the one virtual, you can say this is a machine without an operating system which holds your machine learning algorithm. And you can go with IAM role as is. And again, it asks you to choose the instance type. So based on the computation utilized by your algorithm, you can choose this and rest of the things is there. and it asks you to configure your input data, which is obviously S3 bucket. So if you are new to machine learning, I am revising this definition once again. So machine learning, what it will do, it will learn from the input data set. So there will be one trained data set. It will try to map the incoming data with that data set. So you have to create that input data configuration, which is obviously S3 bucket. It's nothing but you will create a data sets in S3 buckets. So if you don't know what is S3 bucket, S3 is a kind of a storage which stores unstructured data. So you have your data sets as S3 buckets for your machine learning. So if you look at that cats and dogs example, there will be one cats bucket, one dogs bucket. You will configure them here, give them names of cats bucket and dogs bucket, from where your machine learning will take the data set reference. And then you have output data configuration. So the end results, suppose you have feed in a cat image to your machine learning algorithm, so it will respond you back. The output has to be stored at something, right? Again, it's S3 bucket. You can set up that. You can give your S3 location, and all of your output details will be stored in that S3 bucket. Right, and going back, so we have talked about notebook instances. So if you want to make it available in Git repositories, yes, you can do that. And lifecycle configurations. You can create a lifecycle for your scripts. You can do that. Like if you want to terminate after some period of time, or if you want to stop, you can do that using your lifecycle. And then processing jobs, we talked about it just now. And training. Now you have to train your model, right? And how you do that? You train your data set. Training is nothing but making all the data available to your model. Like in that cats and dogs example, there is cats, dogs, right? If you took that, take that Facebook example, so you have to write an algorithm to fetch the user data and create a data set. And the data sets of millions of users will be available there, right? So all of that is nothing but training your model. And there are training algorithms here. You can create an algorithm and training jobs. So create a training job here. It will take me to here. Again, you have to name everything here, give a name, and it's asked you your IAM role, and you can choose your algorithm source here, whether it's a built-in algorithm or if you're working with some third party, or if you have some work done already, you can use that. And then you have this hyperparameters. Let me go back. Hyperparameters tuning jobs. So not only training your job, training we know is nothing but telling your algorithm to how to check the input data and how to map the data set. And then what is hyperparameter? Then your machine learning has to learn itself. It has to update itself. It has to customize itself, change itself according to the new data items coming to it. And on what basis? You will tell it in hyperparameter. According to runtime or the time taken for processing and other things, you set parameters here. So apart from input parameters, you will set hyperparameters, which is tuning your job. Your job itself, it tune itself. Your machine learning, that's why it's called as machine learning, right? It can learn on itself. And using this hyperparameter, you can set a parameter like a basis on which it can tune its job. Okay, and there are other things again for inference. And AWS marketplace is there where you can purchase templates, more templates, apart from the examples provided by AWS. So the popularly used algorithms and templates will be available in AWS market. So rather than developing from the scratch, you can go and buy those model packages and algorithms. So that's about AWS SageMaker, which is used to build machine learning. Okay, guys, any doubts? I'm posting a new poll. Any doubts, guys? No. Okay. Tomorrow we will talk about machine learning platforms and other services available on Azure also. Okay. Okay, guys, tomorrow we will talk about Azure platforms and some IoT and data analytics applications. So cloud is the combination of IoT and machine learning. Cloud has a lot of services. You can just store your data on cloud also without actually using that. You just store your data. You can have only database on the cloud without touching machine learning and other things, IoT. Um, right, most of the people who use cloud, they don't send IoT data. So send the attendance link. Need permission for attendance. Chat. I think it's already posted. Attendance link somewhere here. And here is a sticky message section. I'll paste it here. Post. So is it asking permission? Need permission. Okay. Guys, is the attendance link is asking for permission for everyone? Same problem again. Just give me a minute, guys. Okay, guys, I think this link has to be made public. It's some no need to worry about your attendance. It will be taken in back end. So the people who had been there for up to 7:15 or something, on that basis, your attendance will be marked. No need to worry about marking your attendance, since it's issue on our end. The page, yes, need permission. So no need to worry about that. Your attendance will be marked. Okay, IoT 360 YouTube link, please. Link, yeah, you can search on YouTube, Lango. So let me, even I need to search. Okay, thank you. Thank you, guys. Hope you all enjoyed the session. See you tomorrow.